The universe is a place of endless wonder, filled with phenomena so bizarre and extraordinary that they seem to defy logic itself. From cosmic whispers that echo across billions of light years to objects so dense they warp the very fabric of space and time, the cosmos holds secrets that challenge everything we think we know about reality. These aren't just scientific curiosities, they're mind-bending mysteries that push the boundaries of human understanding. Today, we're diving into 10 of the most astonishing cosmic phenomena ever discovered, each one more unbelievable than the last. These aren't just distant oddities, they're clues to the very nature of existence waiting to be unraveled. And the first one we'll explore is so strange, it might just make you question what's truly possible in this vast, mysterious universe. Imagine a place in space where gravity is so powerful, it bends the rules of reality itself. A place where even light, the fastest thing in the universe, can't escape. This is the realm of black holes, cosmic monsters that devour everything in their path. At the heart of every black hole lies an invisible boundary called the event horizon. Think of it as the ultimate point of no return. Once something crosses this line, it's gone forever, swallowed by the black hole's insatiable hunger. But what makes black holes truly mind-bending isn't just their destructive power, it's the mysteries they hold. The legendary physicist Stephen Hawking once described them as cosmic enigmas, challenging everything we thought we knew about the universe. One of the biggest puzzles is the so-called information paradox. According to the laws of physics, information, like the details of what makes up a star or a planet, can't just disappear. But when something falls into a black hole, it seems to vanish completely. Where does it go? Scientists are still grappling with this question, and it's a problem that could rewrite our understanding of reality itself. In 2019, we got our first real glimpse of a black hole, thanks to the Event Horizon Telescope. The image showed a glowing ring of light surrounding a dark void, a shadow of the event horizon itself. It was a groundbreaking moment, proving that these cosmic giants aren't just theoretical. They're real, and they're out there, shaping the universe in ways we're only beginning to understand. But as strange as black holes are, they're just the tip of the cosmic iceberg. The universe is filled with phenomena even more bizarre, each one pushing the limits of what we thought was possible. And the next one we're about to explore is just as mysterious, if not more so. Now, let's shift our focus to something even more elusive, something that makes up a staggering 27% of the universe, yet we can't see it, touch it, or even detect it directly. This is dark matter, the invisible force that holds the cosmos together. Imagine the universe as a grand cosmic dance, with galaxies swirling and spinning in perfect harmony. But here's the catch: the gravity of the stars and planets we can see isn't strong enough to keep these galaxies intact. So, what's holding them together? The answer lies in this mysterious, invisible substance we call dark matter. Think of it like an unseen hand, gently guiding the structure of the universe. Without dark matter, galaxies would fly apart, and the universe as we know it wouldn't exist. Yet, despite its critical role, dark matter doesn't interact with light or any form of electromagnetic radiation. It's completely invisible to our telescopes, leaving scientists to infer its presence through its gravitational effects. It's like trying to study a ghost by watching how it moves the furniture. So, what exactly is dark matter? That's the million-dollar question. Scientists have been searching for answers for decades, using some of the most advanced tools ever built. Take the Large Hadron Collider, for example, a massive particle accelerator buried beneath the border of France and Switzerland. It smashes particles together at nearly the speed of light, hoping to create or detect dark matter particles. So far, the results have been inconclusive, but the search continues, driven by the tantalizing possibility of uncovering one of the universe's greatest secrets. Dark matter is a reminder of how much we still don't know about the cosmos. It's a cosmic puzzle piece that doesn't quite fit yet, but its influence is undeniable. And while we've made incredible strides in understanding the universe, dark matter shows us that there's still so much left to discover. But as mysterious as dark matter is, it's just one piece of the cosmic puzzle. The universe has even more surprises in store, phenomena that challenge our understanding of space, time, and reality itself. And the next one we're about to explore is just as baffling, if not more so. Now, let's turn our attention to something even more perplexing than dark matter, a force so strange and powerful that it's literally tearing the universe apart. This is dark energy, the mysterious driver behind the accelerating expansion of the cosmos. Imagine the universe as a balloon constantly inflating, but instead of slowing down over time as you might expect, it's speeding up. Galaxies are drifting apart faster and faster, as if some unseen force is pushing them away from each other. That force is dark energy, and it makes up a staggering 68% of the universe. Here's the mind-blowing part. Dark energy doesn't just exist, it dominates. It's stronger than gravity, the force that holds planets, stars, and galaxies together. While gravity pulls things inward, dark energy pushes outward, stretching the fabric of space itself. It's like a cosmic tug of war, and dark energy is winning. The discovery of dark energy was one of the most shocking moments in modern science. In the late 1990s, astronomers studying distant supernova exploding stars noticed something strange. These supernovae were dimmer than expected, meaning they were farther away than they should have been. The only explanation: the universe wasn't just expanding, it was accelerating. This revelation turned our understanding of the cosmos upside down and earned the researchers the Nobel Prize in Physics. But what exactly is dark energy? That's where things get even more mysterious. One leading theory comes from none other than Albert Einstein, who proposed something called the cosmological constant. Originally, Einstein introduced this concept to explain a static universe, but when the universe was found to be expanding, he called it his biggest blunder. Ironically, the cosmological constant might actually be the key to understanding dark energy, a kind of energy inherent to space itself, pushing galaxies apart. Other theories suggest that dark energy could be tied to new, undiscovered particles or even modifications to the laws of gravity. But for now, it remains one of the greatest unsolved mysteries in science. What we do know is that dark energy is reshaping our understanding of the universe. It's not just expanding, it's accelerating, and that has profound implications for the ultimate fate of everything we see. As we grapple with the mysteries of dark energy, it's clear that the universe is far more dynamic and far stranger than we ever imagined, but the cosmos isn't done surprising us yet. There are even more bizarre phenomena out there, each one challenging our understanding of reality in ways we're only beginning to comprehend. And the next one we're about to explore is just as astonishing. Now, let's journey to the aftermath of a cosmic explosion so powerful that it leaves behind one of the most extreme objects in the universe, a neutron star. Imagine a star much larger than our Sun reaching the end of its life. Instead of fading quietly, it goes out with a bang, a supernova so violent that it outshines entire galaxies. What remains is a neutron star, a city-sized object so dense that a single sugar cube of its material would weigh billions of tons. That's right, billions. To put it in perspective, if you could scoop up a teaspoon of neutron star matter, it would outweigh Mount Everest. Neutron stars are the ultimate cosmic leftovers, born from the collapse of a massive star's core. When the star explodes, its outer layers are blasted into space, but the core collapses inward, crushed by its own gravity. The pressure is so intense that protons and electrons are forced together, merging into neutrons. The result, a neutron star, a spinning, ultra-dense sphere that defies imagination. But neutron stars aren't just dense, they're also incredibly dynamic. Some of them, known as pulsars, emit beams of radiation from their magnetic poles. As the star spins, these beams sweep across space like a cosmic lighthouse, sending out regular pulses of light, radio waves, and even X-rays. In fact, it was these pulses that led to the discovery of neutron stars in the late 1960s. Astronomers detected a strange, rhythmic signal coming from deep space, ticking like a clock. At first, they even considered the possibility that it might be a message from an alien civilization. But the truth was even more fascinating. It was a pulsar, a rapidly spinning neutron star. One of the most famous examples is the Crab Nebula pulsar, the remnant of a supernova observed by Chinese astronomers in the year 1054. Today, it spins 30 times per second, sending out pulses of energy that light up the surrounding nebula. It's a breathtaking reminder of the raw power of neutron stars. Then there are magnetars, neutron stars with magnetic fields so strong they could wipe out data on every credit card on Earth from thousands of miles away. These cosmic powerhouses are so intense that they can produce starquakes, violent tremors on their surfaces that release bursts of gamma rays, the most energetic form of light in the universe. Neutron stars push the limits of physics, challenging our understanding of matter, gravity, and the very fabric of space-time. They're a testament to the extremes the universe can create, and studying them helps us unravel the mysteries of how matter behaves under conditions we can't replicate on Earth. But as mind-bending as neutron stars are, they're just one example of the universe's ability to defy our expectations. The cosmos is full of phenomena that stretch the boundaries of what we thought was possible, and the next one we're about to explore is no exception. Now let's turn our gaze to something so bright it outshines entire galaxies: quasars, the most luminous objects in the universe. Picture this: a single quasar can emit more energy than 1 trillion suns combined. That's not just bright, it's unimaginably bright. But what exactly is a quasar, and how does something so powerful even exist? At the heart of every quasar lies a supermassive black hole, millions or even billions of times more massive than our Sun. But unlike the black holes we've talked about earlier, quasars aren't just cosmic vacuum cleaners. They're cosmic powerhouses. As matter spirals into the black hole, it forms a swirling disk of superheated gas and dust. This disk heats up to millions of degrees, glowing so intensely that it can be seen from billions of light years away. It's like a cosmic lighthouse shining across the universe with unparalleled brilliance. Quasars aren't just fascinating because of their brightness, they're also time machines. The light we see from quasars today began its journey billions of years ago when the universe was young. By studying quasars, astronomers can peer back in time, uncovering clues about how galaxies formed and evolved. In fact, quasars played a crucial role in the early universe, acting as cosmic beacons that illuminated the darkness of the cosmos. One of the most intriguing aspects of quasars is their connection to galaxy formation. Scientists believe that quasars are the active cores of young galaxies, powered by their supermassive black holes. Over time, as the black hole consumes the surrounding material, the quasar fades, leaving behind a mature galaxy. It's like watching a cosmic caterpillar transform into a butterfly, a process that takes billions of years but shapes the universe as we know it. Astronomers have been studying quasars for decades, using some of the most advanced telescopes ever built. The Hubble Space Telescope, for example, has captured stunning images of distant quasars, their light piercing through the cosmic fog like a beacon in the night. These observations have revealed not only the incredible power of quasars, but also their role in the grand story of cosmic evolution. Quasars remind us that the universe is a place of extremes, where unimaginable energy and light coexist with the deepest mysteries of space and time. They're a testament to the dynamic, ever-changing nature of the cosmos, and they offer a glimpse into the universe's earliest days. but as bright as quasars are, they're just one piece of the cosmic puzzle. The universe has even more wonders to reveal, each one shedding light on the intricate dance of matter, energy, and time. And the next phenomenon we're about to explore is just as illuminating, though in a very different way. Now, let's dive into one of the most explosive and mysterious events in the cosmos, gamma-ray bursts. Imagine an explosion so powerful that it releases more energy in a few seconds than our Sun will emit over its entire 10 billion-year lifetime. These aren't just cosmic fireworks, they're the most energetic explosions in the universe, and they're happening all around us, billions of light years away. But what causes these cataclysmic events, and what would happen if one occurred closer to Earth? Gamma-ray bursts, or GRBs for short, come in two main flavors. The first type is born from the death of a massive star. When a star many times larger than our Sun exhausts its fuel, it doesn't go quietly. Instead, it collapses under its own gravity, triggering a supernova so violent that it unleashes a jet of gamma rays, the most energetic form of light, shooting out into space at nearly the speed of light. The second type occurs when two neutron stars, those ultra-dense remnants of dead stars we talked about earlier, collide in a cosmic crash. The result: a burst of gamma rays so intense it can outshine entire galaxies. But how do we detect these fleeting, high-energy events? That's where satellites like NASA's Swift Observatory come in. Launched in 2004, Swift is like a cosmic watchdog, constantly scanning the skies for gamma-ray bursts. When it detects one, it quickly swivels its instruments to capture the burst in real time, giving astronomers a front-row seat to these explosive events. Thanks to Swift and other observatories, we've learned that gamma-ray bursts are incredibly common, happening about once a day somewhere in the universe. One of the most famous gamma-ray bursts occurred in 2008. Known as GRB 080319b, it was so bright that for a brief moment it was visible to the naked eye from Earth, despite being 7.5 billion light-years away. That's halfway across the observable universe. It was a stark reminder of just how powerful these events are. But what if a gamma-ray burst happened closer to home? The consequences could be catastrophic. A nearby burst within a few thousand light-years could strip away Earth's ozone layer, exposing the planet to harmful ultraviolet radiation from the Sun. Some scientists even speculate that a gamma-ray burst might have played a role in one of Earth's mass extinctions millions of years ago. Thankfully, the odds of such an event happening in our cosmic neighborhood are incredibly low, but it's a chilling reminder of the universe's raw power. Gamma-ray bursts are more than just cosmic explosions. They're windows into the universe's most violent processes. They reveal the extremes of stellar life and death, the collisions of unimaginably dense objects, and the sheer energy that courses through the cosmos. And while they're incredibly destructive, they also help us understand the delicate balance that allows life to exist in the universe. But as awe-inspiring as gamma-ray bursts are, they're just one example of the universe's capacity for chaos and creation. The cosmos is full of phenomena that challenge our understanding of reality, and the next one we're about to explore is no less astonishing. Now, let's venture into the realm of the truly theoretical, a cosmic concept so strange that it flips everything we know about black holes on its head. What if, instead of devouring everything in their path, there were cosmic objects that expelled matter and energy? Enter white holes, the hypothetical opposites of black holes. While black holes are known for their insatiable appetite, pulling in everything that crosses their event horizon, white holes are thought to do the exact opposite, spitting out matter and energy into the universe. But here's the catch: no one has ever seen one. White holes emerge from the same equations that describe black holes, Albert Einstein's theory of general relativity. In fact, they're mathematically possible, but that doesn't mean they exist. Think of them as the yin to a black hole's yang. If a black hole is a one-way street into oblivion, a white hole would be a cosmic firehose blasting matter and energy outward. But why haven't we found one? One reason is that white holes are thought to be incredibly unstable. Imagine trying to balance a pencil on its tip. It might stay upright for a moment, but the slightest disturbance would send it tumbling. Similarly, white holes might exist only briefly before collapsing or transforming into something else. Some physicists even speculate that white holes could be the other end of black holes, connected by a theoretical tunnel through space-time called a wormhole. Picture this: you fall into a black hole, and instead of being crushed into oblivion, you're spat out through a white hole in another part of the universe, or even another universe entirely. It's a mind-bending idea that sounds like science fiction, but it's rooted in the math of Einstein's equations. So why do scientists even entertain the idea of white holes if we've never observed one? For one, they challenge our understanding of space-time and the fundamental laws of physics. They force us to ask questions like, what happens to the information that falls into a black hole? Could it re-emerge through a white hole? And if so, what would that mean for the nature of reality? Physicists like Carlo Rovelli have explored these questions, suggesting that white holes could be the remnants of ancient black holes that have evaporated over billions of years through a process called Hawking radiation. It's a fascinating idea, but one that remains purely theoretical for now. White holes remind us that the universe is full of possibilities, even if they exist only in the equations of physicists. They challenge us to think beyond what we can see and to imagine a cosmos that's far stranger and more interconnected than we ever imagined. But as intriguing as white holes are, they're just one piece of the cosmic puzzle. The universe has even more mysteries waiting to be uncovered, phenomena that push the boundaries of our understanding and reveal the true complexity of space and time. And the next one we're about to explore is no less astonishing. Now, let's turn our attention to a cosmic mystery that's pulling us literally toward the unknown. Deep in the universe, there's a region of space so massive and so powerful that it's tugging entire galaxies, including our own Milky Way, toward it. This is the Great Attractor, a gravitational anomaly that has puzzled scientists for decades. Imagine a force so strong that it's bending the paths of galaxies, drawing them in like moths to a flame. But what exactly is the Great Attractor, and why is it so hard to see? The story of the Great Attractor begins with the motion of galaxies. In the 1970s, astronomers noticed something strange. Galaxies in our local universe weren't just drifting aimlessly. Instead, they were all moving in the same direction, as if being pulled by an invisible hand. This motion couldn't be explained by the gravity of nearby galaxies alone. There had to be something bigger, something more massive, exerting its influence. That something is the Great Attractor, a region of space located about 250 million light-years away, in the direction of the constellation Centaurus. But here's the catch: we can't see it directly. The Great Attractor lies behind the dense dust and stars of our own Milky Way, in a part of the sky astronomers call the zone of avoidance. It's like trying to spot a distant mountain through a thick fog. Despite this obstacle, scientists have used indirect methods to map its influence. By studying the motion of galaxies and the way their light is distorted by gravity, a phenomenon called gravitational lensing, they've pieced together a picture of this cosmic heavyweight. So, what could the Great Attractor be? One leading theory is that it's a massive cluster of galaxies bound together by gravity. These clusters can contain thousands of galaxies, each with billions of stars, creating a gravitational pull strong enough to influence the motion of galaxies millions of light-years away. Another possibility is that the Great Attractor is a concentration of dark matter, the invisible substance that makes up most of the universe's mass. Dark matter doesn't emit light, but its gravitational effects are undeniable, and it could be the hidden force behind the Great Attractor's pull. To visualize this, imagine the universe as a vast cosmic web, with galaxies strung along its filaments like beads on a string. The Great Attractor sits at a node in this web, a point where multiple filaments intersect, creating a gravitational hotspot. It's a reminder that the universe isn't just a random scattering of stars and galaxies, it's a structured, interconnected network, shaped by forces we're only beginning to understand. The Great Attractor isn't just a curiosity, it's a window into the hidden forces that govern the cosmos. It shows us that even in the vastness of space, everything is connected, from the smallest galaxy to the largest structures in the universe. And as we continue to study it, we're uncovering clues about the nature of gravity, dark matter, and the very fabric of the universe itself. But the Great Attractor is just one piece of the cosmic puzzle. The universe is full of hidden forces and mysterious phenomena, each one revealing a little more about the intricate dance of matter, energy, and time. And the next one we're about to explore is just as enigmatic, if not more so. Now, let's shift our focus to a cosmic mystery that's as fleeting as it is fascinating: fast radio bursts, or FRB. Imagine a burst of radio waves so powerful that it releases more energy in a millisecond than the sun does in an entire day. These aren't just random blips in the cosmos, they're some of the most intense and enigmatic signals ever detected. But here's the kicker: they last for just a fraction of a second, and their origins remain one of the biggest puzzles in modern astronomy. Fast radio bursts were first discovered in 2007, when astronomers sifting through old data noticed a strange one-off signal. Since then, hundreds of these bursts have been detected, each one coming from a different corner of the universe, billions of light years away. What makes them so intriguing is their sheer power and their unpredictability. They flash into existence, lighting up radio telescopes for a brief moment, and then vanish without a trace. So, what could possibly produce such a brief but intense burst of energy? The theories are as varied as they are fascinating. One leading idea is that FRBs come from highly magnetized neutron stars known as magnetars. These cosmic powerhouses, with magnetic fields trillions of times stronger than Earth's, could produce bursts of energy as they undergo starquakes or magnetic explosions. Another possibility is that FRBs are the result of collisions between neutron stars or black holes, events so violent they send shockwaves rippling through space. But not all FRBs are one-time events. Take FRB 121102, for example, a fast radio burst that doesn't just flash once but repeats. Discovered in 2015, this repeating burst has been observed multiple times, each one coming from the same location in a distant galaxy. This has led some scientists to speculate that FRBs could be tied to exotic cosmic objects, like pulsars or even alien megastructures. Yes, you heard that right. Some have even suggested that FRBs could be signals from advanced extraterrestrial civilizations, though this remains a highly speculative idea. Detecting and studying these bursts is no easy feat. Because they last just milliseconds, astronomers have to be incredibly quick to catch them. Radio telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, are constantly scanning the skies, searching for these elusive signals. When a burst is detected, telescopes around the world swing into action, trying to pinpoint its origin and gather as much data as possible before it disappears. Fast radio bursts are more than just cosmic curiosities. They're windows into the most extreme environments in the universe. They challenge our understanding of how matter and energy behave under conditions we can't replicate on Earth. And while we've made progress in detecting and cataloging them, their true nature remains a mystery, reminding us just how much we still have to learn about the cosmos. But as puzzling as fast radio bursts are, they're just one piece of the universe's grand puzzle. The cosmos is full of phenomena that defy explanation, each one adding another layer to the mystery of existence. And the next one we're about to explore is no less astonishing, a phenomenon so strange it might just rewrite the rules of physics itself. Now, let's tackle one of the most profound questions humanity has ever asked. Are we alone in the universe? On the surface, it seems almost impossible that we could be. The universe is unimaginably vast, with hundreds of billions of galaxies, each containing hundreds of billions of stars. Many of those stars have planets, and some of those planets are likely to be Earth-like with the right conditions for life to emerge. So, where is everyone? This is the heart of the Fermi Paradox, a question that has puzzled scientists and thinkers for decades. The paradox is named after the physicist Enrico Fermi, who famously asked, "Where is everybody?" During a casual conversation in the 1950s, Fermi wasn't just being philosophical, he was pointing out a glaring contradiction. If the universe is so vast and ancient, and if life is even remotely common, why haven't we found any evidence of extraterrestrial civilizations? To explore this question, scientists have turned to tools like the Drake equation, a formula developed by astronomer Frank Drake in the 1960s. The equation estimates the number of intelligent civilizations in our galaxy by considering factors like the rate of star formation, the fraction of stars with planets, and the likelihood of life developing on those planets. The problem, many of these factors are still unknowns, leaving the equation open to wildly different interpretations. Some estimates suggest there could be thousands of civilizations out there, while others imply we might be the only ones. So, why haven't we heard from anyone? There are plenty of theories. One possibility is that intelligent life is incredibly rare. Maybe the conditions needed for life to evolve into a technologically advanced civilization are so specific that Earth is a cosmic fluke. Another idea is that intelligent civilizations might self-destruct before they can make contact, whether through war, environmental collapse, or some other catastrophe. Then there's the challenge of interstellar communication. The distances between stars are so vast that even if civilizations exist, sending signals across the void would take thousands or even millions of years. By the time a message reaches us, the civilization that sent it might be long gone. Carl Sagan, one of the most passionate advocates for the search for extraterrestrial life, believed that the universe is teeming with life, but that we're simply too young and too isolated to find it yet. He famously said, "The universe is a pretty big place. If it's just us, seems like an awful waste of space." The Fermi Paradox isn't just a scientific puzzle, it's a mirror that reflects our own place in the cosmos. It forces us to confront questions about the fragility of life, the challenges of survival, and the vastness of the universe. Are we alone, or are we just one voice in a cosmic chorus waiting to be heard? As we ponder these questions, we're reminded that the universe is full of mysteries, each one inviting us to explore, to wonder, and to dream. And while we may not have all the answers yet, the search itself is a testament to our curiosity and our desire to understand the cosmos and our place within it. But as we wrap up our journey through these 10 astonishing cosmic phenomena, one thing is clear. The universe is far stranger, far more mysterious, and far more beautiful than we ever imagined. And the more we learn, the more we realize how much there is still to discover. So, what do you think? Are we alone? Or is the cosmos alive with possibilities, waiting for us to reach out and find them? The answer, like the universe itself, is out there just waiting to be uncovered. From the crushing gravity of black holes to the invisible pull of dark matter, the universe is a place of endless wonder and mystery. We've journeyed through 10 of the most astonishing cosmic phenomena, each one more mind-bending than the last. Black holes, those cosmic vacuum cleaners, challenge our understanding of space and time. Dark matter, the invisible glue holding galaxies together, reminds us how much of the universe remains hidden. Dark energy, the mysterious force accelerating the expansion of the cosmos, hints at a future we can barely comprehend. We've marveled at neutron stars, city-sized objects so dense they defy imagination, and quasars, the brightest beacons in the universe, shining across billions of light years. We've witnessed the raw power of gamma-ray bursts, explosions so intense they outshine entire galaxies in seconds. We've pondered the existence of white holes, the theoretical opposites of black holes, and the Great Attractor, a gravitational anomaly pulling galaxies toward the unknown. And let's not forget fast radio bursts, fleeting, enigmatic signals that flash across the cosmos in milliseconds, or the Fermi Paradox, the haunting question of whether we're alone in the universe. Each of these phenomena pushes the boundaries of what we thought was possible, challenging us to rethink our place in the cosmos. These mysteries aren't just scientific curiosities, they're invitations to explore, to question, and to dream. They remind us that the universe is far stranger and more beautiful than we ever imagined, and that there's still so much left to discover. So, what do you think? Which of these cosmic phenomena fascinates you the most? Is it the mind-bending physics of black holes, the invisible influence of dark matter, or the explosive power of gamma-ray bursts? Let us know in the comments below. We'd love to hear your thoughts. If you enjoyed this journey through the cosmos, don't forget to hit that subscribe button and ring the notification bell. There's a universe of mysteries waiting to be explored, and we're just getting started. Together, let's keep uncovering the wonders of the universe, one mind-blowing discovery at a time. Thanks for watching, and until next time, keep looking up.